Spitzer, of course, is now only operating 2 channels on 1 instrument. It's not too functional yet left. It was a magnificent mission. I wish it was still ongoing, but it did a lot of planet detection. You'll find a lot of information there. Of course, Kepler, which finally stopped functioning, but just for that short time it was up, it discovered in more than 4,000 exoplanet candidates, and almost 1,000 of those, I believe, around 978 or so, have now been confirmed to be exoplanets, just in that short amount of time. We can also detect planets, because we can do sub-millimeter astronomy from the surface of the Earth, ground-based. Of course, the atmosphere provides a lot of interference, either due to its opacity or emissions within the atmosphere itself. But if you go to a place like Mauna Kea in Hawaii or the high plateaus in Chile, then there are large radio telescope sites there that have detected some very wonderful observations of planets. So once again, remember, the main sequence, exoplanets can form around any spectral class star. We have Fomalhaut this time, which is spectral class A. A lot of them, of course, are much less massive. A lot of them around the red dwarfs. Some of them are even around brown dwarfs that are not main sequence stars. But brown dwarfs come close to the main sequence. I mean, the fusion process kind of starts a little bit. There's a lot of some sputtering, and it's a little bit of fusion, but it never really stabilizes to become steady hydrogen to helium fusion. But it does come close, and you can see this where the hot Jupiters are. They don't come as close to the main sequence as the brown dwarfs do, but they are not too far apart in temperature. Do not forget, still, spectroscopy is how we see an image and get information about the universe. And so you still have to be knowledgeable about spectra, both the images and the plots in all of their different ways. This is no different. We've had this on every single astronomy event. There's nothing new and different. Of course, the radiation laws is still very important. Planck's law that basically says that a hotter star will emit more energy at every single wavelength than a cooler star. Wayne's law, which basically says that every single object emitting radiation has one wavelength which it radiates the most energy, and that wavelength, that peak wavelength, is directly related to the temperature. And then Stefan-Boltzmann Law, which basically says that the area under the curve is equal to the total power output of the star, which of course, obviously, depends upon the temperature and the surface area and the radius and the dimensions of the star itself. The basic equations are the same. The distance modulus, Kepler's laws, there's no difference. They just apply to exoplanets and stars rather than stars and stars as we have had in the past. The only new one up here is the equilibrium temperature. And this is a relationship that basically treats a planet itself as sort of a black body. That ignoring any atmospheric conditions or clouds, assuming that all of the energy from the parent star is absorbed by the planet and then emitted by the planet, this gives the effective temperature, which gives an idea of the habitability of that planet. So, once again, the Chandra website has the webinars are posted at the Chandra website. A lot of content is there, a lot of images are there. 3 or 4 of these objects are in the Chandra photo album, which gives you all the information you need about those objects. Yes, X-ray observatories can image exoplanets, strange but true. The APOD is another, down here, Astronomy Picture of the Day. APOD is a good place to do a search for these objects. And the AAVSO website will have all of the previous events listed. It will have the link to the Chandra webinar. It will have this PowerPoint posted on it. And it also has the variable star astronomy curriculum, which gives a lot of information about stellar evolution too. So these are the major places where you should go. In fact, they're the only places you should really go for information, unless you're going to the specific sites of the missions themselves that actually detected these exoplanets. The SOSI, the National Science Olympiad website, also has a list of resources and links. No, the coach's manual. Actually, we are going to repeat planet formation dealing with stars and exoplanets for the 2016 competition also. The main focus will not change, only the deep sky objects. So sometime before that happens, before next year, this manual will not be revised in time to be useful, I do not think, for this year's competition. However, I'm going to write a large section. Tad Kamasic and I are going to write a section on exoplanets to add to this. So there is another place to go for resources. So, if you have any questions about the rule or event description itself, please go to the rules clarification menu on the National Science Olympiad website and post your question there so that anybody who has that same question can look and see and read the answer. If you have any other questions whatsoever, then you can either contact Tad or myself. So read the event description, make sure you know what the topic is, make sure you know what you can bring to the event, only use the resources that have been talked about in this presentation, and use the coach's manual, use prior events. Now the prior events are not going to help you too much this year since we've never done exoplanets before and that part is all new. But look at the format, because the format never changes. We always have 3 sections. The first section is more basic ID and questions relating to stellar evolution and exoplanets. The middle section will have some basic mathematics with it, and the third section will have more extensive, more in-depth, more process-oriented mathematics and questions. So that will give you an idea of how your team should split what their contribution is going to be during the event. So if you have any further questions, ask Tad or myself. Otherwise, pay attention to this webinar, and I wish you the best of luck for the 2015 competition.